Okay, so continuing on, I probably should have just finished up the disposal of the hamburger in the last video because the bulk of what we need to do is already in place. Because as I said, one of the reasons why we took the approach that we did is that we can now flag that the fact that the hamburger has been clicked, and then based on it being clicked and what you click after the hamburger, such as the bun, it then gives instructions. So in this case, we're going to click on the hamburger and then click on the trash, and we don't have to move the hamburger, so we don't need to grab the coordinates of the trash. We just need to destroy the hamburger. So this procedure is going to look really, really familiar. We're going to right-click, create C# script. We'll call this trash bin. We click on a trash bin. And I believe in the last video we put on the box collider, so make sure that's there. We put the trash bin script on the trash bin, and then we go ahead and open that up. In that, what we're going to do is we're going to have an on mouse down, just like the other scripts, and we're going to have a variable be changed when you click on the object. So we're going to go back to our game flow script, and we're going to create public static string, and it's going to be is trash clicked, and it'll be set to no. So again, it's static because we need this variable to be accessible throughout the entire application. So that's been created. That variable has been declared in game flow. We now go to trash bin, and that will now be accessible. So void on mouse down. Again, case sensitive, be careful of that. And that new variable, gameflow dot is trash clicked, gets set to Y. We now go to our hamburger. So we want patty con, and what we want to do is if the hamburger has been clicked, and if that and the trash has been clicked, we then want the hamburger to be destroyed. So again, the destruction is not going to actually occur in the on mouse down of the hamburger because you click on the hamburger first and then what you want to do with it. So that means it will also the trashing of the hamburger will be done in the update section. So let me think about this because we might want all these. So place cheese is no. Ketchup is no. Bun chosen, so we don't want this one. Right. Okay. So what we want to do is rather than bun chosen, this will be is trash clicked. So in the update section of the patty con script, which is attached to the hamburger, the patty itself, we're saying if cheese has not been placed, if ketchup is not being placed, if you've clicked on the trash object, and the place patty is set to yes, which happens in the on mouse down when you click on the object, when you click on the patty, then we want something to happen. Destroy game object. That easy. That destroys the object that the script is attached to. The script is attached to the hamburger. I think that's all we need to do. We'll find out in a minute. Okay, so no error messages. Put up a hamburger. We click on it. We click on the trash. Sure enough, that's all it took. And now we just have a little bit of housekeeping, so to speak. So after you've clicked on the trash for the hamburger to be deleted, you then really want to set this back to no. So once you've deleted the object, you want that to be set back to no. That way you're not still deleting other things. And we'll probably have to do some additional cleanup like that later on. Like, for instance, when the cheese is placed and the ketchup is placed, we'll probably need to set those values back. But since you want to test any changes you make, don't want to go through all that right now, but this one I can test to make sure this doesn't break the deletion. So all I did is set is trash clicked and set it back to no after the hamburger has been clicked on and destroyed. So we click on the hamburger, click on the crate, click on the hamburger, click on the trash, and it does still delete successfully. Excellent. So right now, this really isn't that interesting to look at because everything is static. Things just jump into place. There's really no animation. So let's add a particle system, and what we're going to do is when the patty is placed on the grill, the particle system will look like steam. So let's go to Game Object. Let's go to Particle System. And before we begin, I just want to say that working with a particle system is not an exact science. It's like sculpting, and that you're going to make a change, and then you make another change and find out that you might have to undo one of your changes, and it's no big deal. As you can see, there's lots of settings here. You can just freely change them from one to another. So having said that, I might skip around a bit. I might splice the video because there's no point in seeing every little thing as long as I give you the broad strokes. So let's do that right now. So when you have your particle system highlighted, it doesn't look like much because it's really close to the camera and the particles are coming up towards us and they're fairly large. So you have start lifetime, so that's the size of the particle at the beginning. There's start speed, the speed of it at the beginning. You also have things like start color. So you could ask, well, why is it all start this and start that? And that's because if you scroll down here, you'll see that you can change things over lifetime. So size over lifetime, color over lifetime. So a good example of changing size over lifetime is what we're going to do. And that is steam. The particles start off smaller and they balloon. And then as far as changing color over lifetime, you can also change transparency. So they start smaller, denser, they kind of balloon and disappear. So that's the sort of thing we're going to do. And again, I said I'm probably going to jump around, but I do want you to know what these, at least the basic ones, do. And then I certainly highly recommend that you play around with these settings to see what kind of effects you can get. So first, start lifetime, let's bring that down to like 1 second. Start speed, let's bring that down to 1. Now, let's go to shape, and you can now see the shape of what you're looking at, both the top and the bottom. So let's you can grab the little dot here or change it here. We'll shrink this in so it's smaller. We'll also shrink in the top. Okay. Start size, too big. Let's try 0.1. Move this over. And as far as position, -6. Let's take a look to see where the hamburger goes when we click on the hamburger crate, because we'll put it there for now. So 1, -5, -5.7. So 1, -1. Nope, I can see it's actually starting beneath it. Probably because of the way it centers the particle system. I think we said -5.7. So yeah. All right, so it looks like that the size is too big. You can just shrink this in again. Way too few particles. So emission is the rate, and then up here is max particles. If you increase the emission, but you don't increase max particles, you run the risk of having too many, well, not too many particles, but when you hit the max particle, you'll get a dead zone. I'll show you what I mean. So we won't increase max particles, but we'll increase the rate. So that's exactly the right amount. So let's do there. See how you get that like break in the middle, why it's not consistent? Because this is doing exactly what it says. It's saying constrain the particles. Don't let there be more than that. So that's even more distinct. Now, it may turn out that maybe that's what you want. Maybe like you want a ring, you want a break, so be it. But if you don't, then like I said, you have to be careful with this rate. So this rate probably could be as little as like 90. And we want the particle to increase over time. So size over lifetime, you just click here, grid will appear down here. If you notice the top is already 1.0, well, we want it to be bigger than 1.0. So you can just change that. You can just highlight that and say maybe it's 5.0. Now it's starting to look more like a fog or smoke or steam. Now just drag that down, grab that point, and we'll bring it down to the 1.0 mark to begin with. So now it starts small and it gets bigger. So you may want it to change quicker or slower, or some of this is purely relative. Let's run this just to see how it looks in the context of the game. So you've got steam coming up. Now here's one of the problems. It just disappears. That doesn't look great. So what you can do, you can either change the color so it becomes translucent, or you can change the size. Changing the size kind of defeats the purpose though, because we just had it get bigger. Why would we want it to get smaller? So color over lifetime, click on this. Now, instead of using the grid down here, it brings this up. The bottom spots is only 2 to begin with, but you can add more. The bottom is the color, the top is the opacity. So if I say I don't want to change the color, but I want to change the opacity, I click up here, see how it says alpha 255, and I just slide this over. Now, suddenly it becomes translucent like that. So let's run that. Kind of gives it a little bit of a glowy effect, so you might decide that you don't like that. Also, it's white. If we make it like a grayish color, so color over a lifetime, let's click on this, and gray, you basically want the numbers to closely match. See how it says 152 across the board? If these numbers match, you're going to get some kind of gray. So 152 across the board, that's easy enough to replicate. 52. And we'll also set the start color just for consistency purposes. There we go. That's pretty good. I'm fairly happy with that. And again, it's arbitrary. You may decide that you want it to be a little bit more distinct. Maybe you want it to be a little bit more cartoonish. There's a lot you can do. And particle systems in itself is many videos worth of tutorials. There's just so much to handle. Now it looks a little bit silly because there's nothing there. But if we put a hamburger there, so in the context of the hamburger, Sony doesn't look so bad. And it's lined up pretty close too. Just push this over a tiny bit. Now, of course, we don't want the steam there at first. We only want it to show up once the hamburger has been placed. So what we do is we take our particle system. We're just going to rename this. Let's call it steam. We'll turn it into a prefab. We'll delete the one from here. And what we want is we want the patty to be aware of the steam particle system so it can instantiate it. So we will go to the patty script. and put it up here. Actually, we'll do this in order of addition in case I ever have to troubleshoot these retroactively. So public transform, and it will be Steam obj. Again, I want to know that it's an object. We have our Patty selected, Steam obj. We'll put the Steam object on it. And what's going to happen is we want the Steam to be instantiated when the hamburger is. Now this is an example where you could use this, the start delay. Well, maybe you don't want it to appear right away. Maybe you want it to be in the grill for like 10 seconds and then you want the steam to show up. So that's one of the reasons why you'd have a start delay. Okay, so the hamburger patty is now aware, for want of a better term, the steam. Now we need the hamburger patty to instantiate the steam. So what we can do is we can do that right actually in the start section, that as soon as it gets instantiated, the patty gets instantiated, it will then instantiate the particle system, sorry. So Steam object, so what is being instantiated, where it's being instantiated. We'll use the Steam object's own position at the moment. You could, but what we'll probably eventually do, we'll eventually use the hamburgers, but like I said, I don't think this Steam is lined up with the hamburger at the moment. But yeah, eventually this will change. This will need to reflect the hamburger's position or a derivative of the hamburger position. Like it might not be exactly. So, and then we'll use Steam objects rotation. So the three typical arguments: what is being instantiated, where it's being instantiated, and the object rotation. So now we see another iteration of this. We saw a vector 3 actually spelled out x, y, and z coordinates. We've seen another object's position being pulled in, and now we can use its own position. Because it's a prefab, it's got to transform so it has a position. So I think that should do it. Because we've said we've got a new object, we put the object into the variable in the inspector, and then we said instantiate this. Because it's in the start section, it'll only instantiate once, so it's not like it's going to keep instantiating over and over again. All right, let's give this a try. So Steam is no longer in the scene, we deleted it. We placed the patty, and sure enough, I actually kind of like that timing. And then when we click on the hamburger, well, let's put a bun here so it looks right. Then we want the steam to go away. So the steam will need to be destroyed. So we'll give the steam a script as well. And then what that does is if you need to modify some aspect of the steam, you now have a script in place to do that. So create C# steam con, like you want the steam to become smoke, that kind of thing. And we'll put steam here, and we'll apply, I should say attach the script to the Steam object. And then what we'll do is when the hamburger is moved, the steam will be destroyed. And we already have that because we already track that the bun is clicked on. So let's go to, let's see if the patty the patty gets moved here, and the patty gets trashed here. So what we need is for this information to be transferred to the Steam. Let's just create another static variable then. So in GameFlow, public static string destroy. Let's avoid the word destroy since that's a command. Let's call it remove. Actually, that's a command too. All right, we will use destroy. As long as it's not by itself, that's fine. So destroy Steam set to no. Save it. Go to the patty. So if either one of these happens, if either we move it or we destroy it, then GameFlow dot destroy Steam is equal to yes. So because in either case, because in PattyCon, this is what moves this to the bun. This is what moves it to the trash, or to be more accurate, destroys it. So in either case, we want the Steam to stop. So in either case, we want destroy Steam to be set to yes. Save that. Let's open up our SteamCon. And in the update section, if GameFlow dot destroy Steam equals y, then first let's set that variable back. Like I said, we're going to be doing that housekeeping going forward. So destroy Steam. Oops. Sorry, need to put in GameFlow. Getting ahead of myself. GameFlow dot destroy Steam. But you noticed it wasn't in there. It wasn't in the list if I didn't specifically say it's coming from GameFlow. So we'll set that to no. That way, the next Steam that gets instantiated doesn't suddenly destroy on its own. And then destroy game object. It is possible to have one object destroy another. You have to create more variable names. So when you instantiate something, that instantiated version has a name. I really don't want to mess around with that since this is an intermediate tutorial. Not to mention that if we have multiple hamburgers, you would need multiple names for that instantiated item. So it gets very, very messy. So anyone who's more advanced out there and says, hey, you could have just done this. Like I said, doing this for simplicity's sake. So yes, it gives us another script, but it gives you that kind of ultra controllability. So that's it. So that's the Steam script. The Steam script is attached to the Steam object. If this new variable gets set to yes, then Steam gets destroyed. So there's our hamburger, there's their Steam, and the Steam stops. There's our hamburger, there's the Steam stops. So you could set it up so as that the Steam runs its final cycle. So it gets destroyed, but all the particles on the screen disappear first. Again, that's the kind of fine tuning I'm not worried about right now. But at least you've got a little bit of animation now. It's not such a static image. Okay, so that should do it for this one.